Honors Physics, Day 121, Mirrors, problem number 33. Here we have a concave mirror, radius of curvature 60 centimeters. So we know right away that the focal length of this mirror is positive 30 centimeters. Diverging mirrors are convex. This is a concave, converging mirror. So the focal length is 30 centimeters. All right, and we want the image to be real, so we know, once again, from doing previous problems that when the image is real, we have a negative magnification because the negative refers to a flipped image. So we know that in this case, M is negative 3. 3 times the size and flipped, it's real, so negative 3. All right. I think we might have enough information here to solve the problem because we know that from our experience here that M equals negative image distance over object distance, and that basic relationship of 1 over focal length equals 1 over object distance plus 1 over image distance. So we use the algebra here like this, plug in the negative 3 for M. So we have negative 3 equals negative Q over P. Or in other words, simplifying this a little bit, Q equals 3P. All right, and then I'm going to take that and plug it in for Q. Plug that in for Q, and I know F is 30, so I'm going to have 1 over 30 equals 1 over P, object distance, plus 1 over 3P. Solve that equation for P. And what I would do is in that middle fraction or term right here, this term right here, the 1 over P, you could make that 3P over 3P and then add the two fractions and cross multiply, whatever it takes for you. But you're pretty much there. It says where should an object be placed? That'll give you the direct answer for where the object would be. So that would be the answer to part A. If you wanted to do part B of this problem, so that's part A. If you want to do part B of this problem, really the only thing you would change is that you would start off with the initial condition up here, this M right here. You just start off with M equals positive 3 and repeat the process that I just walked you through.